Okay, so today, another day on inequalities. I'm also starting the review for the final. So, you're going to get a couple problems today that are try to recall some of those topics for the final. All right, this one, we just talked about it yesterday. If you knew this rectangle had a perimeter of 220, you should be able to tell me what both sides are in terms of x. Try it. I'm hoping you just go, oh, yeah, it's got to be x and blah. Focus. Pencil's not moving. Making me nervous. All right, so this is x. So then what's the other one? Just did this yesterday. Come on now. Yes, and if you weren't able to do that, you should have at least known that, okay, both of these sides are x here, right? And if I add them all up, that's what perimeter means, right? That if I add up this plus this one plus this one plus this one, add them all up, they should add up to 220. Well, obviously there must be some numbers on these other sides that can add up to the 220. So if I got to have these be the same, then there has to be a 110 here and a 110 here to make it add up to 220. Do you get that logically? And then also, if these are all going to add up to 220, the x's all have to cancel. So this has to be a minus x, and this has to be a minus x, so that there's two x's, and then they get taken away by these, and the last two things get added together, the 110s. So there we go. So x and 110 minus x. All right. Why do we care about that? Because this kind of a problem, you'll have to use that as the starting point, and then you go from there. All right. So start by saying the area is 21. So right away you should say, oh, well, this is x, and what's the other one? Well, they multiply to make 21. So what times x makes 21? Well, I have to get the x's to cancel, right? So come on, say it with authority. 21 over x. Good. Because that way the divide by x and the times x would cancel each other out, right? And you'll have a 21 left. All right. If you haven't gotten that by now, I've done it several days in a row. You got to catch on. That's the easy part. Okay, now what? Now it says perimeter. I haven't even done anything with perimeter yet, so maybe I should write out the formula. Good thing I have smart kids in here that can tell me that formula. Mr. W, perimeter. Correct. Now, I know what L and W are. Mr. P. P, I don't know. But what's L? False. There you go. That's the length. And the width is what? All right. Now, can I do a little bit more on this? Yeah. 21 times 2 is 42 over x plus 2x. Now, how am I supposed to find the minimum perimeter? What if I were to graph this and find the lowest spot? Would that sound like a minimum? That's what you're supposed to do. Grab your calculator, type this in. I would encourage you to put parentheses around any fraction, like that, and then graph it. Then you should look at your window and say, I can't have negative x's, because that would be negative sides on a rectangle. I can't have negative perimeters, which are the y's. So you should go to your window once you got this typed in, and change your window around so that it has the appropriate logical numbers. Like the smallest x should be 0. Once you got it typed in, go to your window and make your x be 0. Your x max, well, that's like how long are the sides on my rectangle? I don't know, maybe 10 isn't, maybe I think they go up to 15. So maybe I'll arrow down and say 15. And then scale, always leave that as 1. Y minimum. Well, y in this case is perimeter. And the perimeter's minimum, well, the smallest perimeter, it probably can't even be 0, but let's say it can't be negative, that's for sure. So let's say 0 to the y max, the biggest perimeter we'd have, I don't know, 25, 30? And then you hit graph. And you'll see a low spot in the graph. If you don't use the window, it will be very confusing. But if you set your window settings like I just showed you, you can get it zoomed in so that you can see the low spot really easy. then use minimum. Second, calculate minimum. I'm going to pause for a second while you get your calculator to do that. Second, calculate minimum. Go to the left of it, go to the right of it, etc. Let me just finish this off and I'll come and help you. Yes, you should put parentheses around it, but you don't really have to. Alright, so this is crucial. You get done with this and you go, okay, I know I wanted x, I wanted to find x. X is 4.58, and you go, okay, x is 4.58. And you go on to the next problem, and you get it wrong. Because, yeah, there was a 4.858 on the calculator, but is that the answer? Is that the perimeter? No, the x is this. You just figured out how long the side would be. The side would be 4.58. And this is kind of weird. If you type in a 4.58 and you do 21 divided by 4.58, guess what you get? 4.58. So what are they saying? The sides should be the same, yes. So it would be a square. And the square's sides are 4.58 by 4.58. And does that have a perimeter? Yes, the perimeter, just add up all four sides, is going to be 18 point something. But you could have found that by looking at another spot on the calculator. The x is 4.58. The y is the perimeter, 18.33. Okay, so I know a lot of you would have gone all the way to the end of that problem and then got it wrong because you didn't think about what you were writing. If you write down 4.58, you're writing down how long the side is. And they wanted the perimeter. So you have to figure out this side and add them all up. There's 4.58s. Final answer, 18.33. Okay? All right, let's move on. It's another review question. We've done so many of these, but so how about this time? You just tell me, how do I start? Multiply by what? 2 times x minus 1. And then I'm going to do the little infinite cloner thing because I can. And I go drag one here, drag one there. Woo. Sorry about that. Yikes. All goofy. There. And then my final answer would end up being a quadratic. And then I'm going to encourage you this time to use the quadratic formula to solve it. Why? Because sometimes you can't factor them. This one, when you're done, will work out really nice if you use the quadratic formula. You'll get 2 answers. Try it. Because I know you haven't done the quadratic formula in a while. Alright, when it's all said and done, you get an equation. And that equation, when you put it into the quadratic formula, gives you 2 answers. And I hope, let's get to the equation first. Cancel, cancel, x squared minus x. Cancel, cancel, 2 times 2 is 4. 3 times 2 is 6, 6 times x is 6x, 6 times 1 is minus 6. Put it all on one side, x squared minus 7x plus 10. And then the, x equals negative b, or opposite of b, which is 7, plus or minus the square root of b squared, 49, minus 4 times a times c, all over 2a. And the a here is 1, so I can just say 2. And that's a 1, and that c is 10. And so then this is really 7 plus or minus square root of 49 minus 40 over 2. And 49 minus 40 is 9. And the square root of 9 is a nice number. So it's 7 plus or minus 3 over 2. So it's 7 plus or minus 3 over 2. So you do it once with plus and once with minus. 7 plus 3 over 2. Ugh, get really sloppy here. Plus 3 over 2. And 7 minus 3 over 2. And that would be 10 over 2, which is 5. And this would be 4 over 2, which is 2. 5 and 2. Now, if your life depended on it, would you, before you told Mr. Hussein what your answer was, and you hope you didn't screw it up, you'd probably check it, wouldn't you? I'd check it. So I'd go back and stick it in. 5 goes in and find out if it actually works. So put in a 5 for x. So I'll ignore that for now. 5 here, 5 here. 5 over 2 is 2.5. 5 minus 1 is 4. 2 over 4 is a half. 2 and a half plus a half makes 3. Yay, it works. Why am I saying this? Because sometimes the answer you get is like 1. Why would 1 have been an unfortunate answer to get? Because you might not have thought to check it. And if you did go back and check it, you'd realize there was a 0 in the denominator, and therefore 1 would be an extraneous answer. An answer that seems like it works, but it doesn't really. All right. This one. Don't even need to do it. We've done many like this. The answer for the top part is 3. The answer for the bottom part is -8 and 2. And now I would just need to check each part. Oh, thank you. Not 2, 1. Now we would just need to check things like 2 or 4 or 0 or -9, and then check each of these spots themselves. How about those for a second? Do they work or not? They do not. The ones that are on the bottom are asymptotes, so this is an asymptote, never works. This is an asymptote, never works. That one, even though it makes it 0, 0 is not less than 0, so that also doesn't work. And then you check the other zones. Okay, remember how to do those? How is this different than that? It's an equation that has a what in it? See, that wasn't an equation, it was an inequality too. That had a less than 0 in it. This has a less than 0 in it. But this one's got a fraction in it. How do I get rid of the fraction? Multiply everything by x plus 6, and then you do it like normal. How about this one? What's different about it? Not much. It might have an imaginary, but actually this one, it comes down to normal. Because 2x squared minus 2 has to equal 0. 2x squared has to equal 2. X squared has to equal 1. And that's just the square root of 1, which is 1. And -1. You see how I got 2 roots out of that? So there's a 1 and a -1. And do they actually work? Well, they make the denominator 0. That's not a good thing. Those are asymptotes. All right, good enough on that. Here's the new stuff. Just a second here. All right, so here's the new stuff. You've got a absolute value in there. It really doesn't change too much. You still do them the same way. You say 2's got to be important. -3's got to be important. And if I put in a 2, it'll become 0 on top, which is less than or equal to 0, so it works. And if I put in a -3 on the bottom, it will never work because that's an asymptote. But then the thing that gets weird is as you're testing your intervals, do you get how the bottom will always be positive? Because it's an absolute value. So you know how you're always like show your work down here and like what's on the top and is it positive or negative and is it positive or negative? The bottom will always be positive. So do you even need to test the bottom? No, not unless it's 0, unless it turns the bottom into 0. Okay, so if I'm going to test a number like 3, I know the bottom is automatically positive. I just have to check the top. And the top, 3 minus 2 would make it 1. Top would be positive also. So I have always the bottom is going to be positive. Positive over a positive gives me a positive. Here, if I check things like 0, if I stick in a 0 here and a 0 here, the bottom's automatically positive. The top is negative. Negative over a positive is a negative. And then -4, put in -4 here and here. Seems like the bottom would be negative, but it's not. It's got to be positive. Top, negative, negative. So where is this thing less than or equal to 0? In this whole zone right here, including the 2. All right. So how would it change it if you had a square root in it? I'd like you to write this one down. This one's worthy of your pen or pencil. All right, still seem like 3's important? It is. Seem like -1 would be important? If I stick in -1, what happens? I get square root of 0. What's that? 0. It's okay. It's not like undefined or anything. It's just 0. And would it work? Yep. So it works here and here because of the or equal to. It works at both those spots. But now here's the weird part. You know your test intervals? What if we test -2? You end up with a negative underneath the square root, don't you? Some people might just gloss over that and say, okay, so that's negative times the other one's negative. Negative times a negative makes a positive. Wrong. You can't have a negative underneath the square root. So what does that make this up here? Imaginary or undefined is the way I'd like you to write it. Undefined. That can be a new option now. Instead of just positive or negative for each little interval, it can be undefined if you got a negative under the root. So let's try this spot. If I check 0, put in a 0 and a 0, I have a negative in front, and then the square root part becomes square root of 1, which is just 1, which is positive. Negative times positive makes a negative. And then over here, when I have like a positive 4, the 4 minus 3 makes positive. And the 4 plus 1 square root of that is positive, is a positive. So see how this got 3 different things now? Instead of just pluses and minuses, I have one more option. All right, so greater than or equal to 0 would be in this zone right here. And I could see somebody writing 3 to infinity with confidence and moving on to the next problem and getting it wrong. Because why? Because also -1 works. So -1 in brackets. Union with 3 to infinity. Okay, yes? All right, so the question though is, you asked when you tested -1, that's the point, is that, okay, I'm sorry. When you test 0, if I put in a 0, I'm not putting in other numbers. Oh, I see what you're thinking. You're thinking that the square root of 1 is both 1 and -1. It's kind of a flaw. You got to get this into your head. When you see a square root sign like this, that means the positive square root of. I know what you mean. You're saying -1 times -1 is also 1, but that doesn't mean the square root of. With this sign right here, we're defining our answer as only being the positive 1. Okay? So that's why that's positive underneath that square root, because it has to be. All right. It's just one of those little definitions. All right. I think that's good enough. We've kind of pounded this stuff. Wait, I got to give you a little final review though. Do you remember when we had sawtooth functions and they like looked like this, and then they'd say that's f of x? So what would this be? Do you remember that? It's been a while now. Can anybody tell me from memory that you still remember what to do? One person does. What do you think? So the stuff down below bounces up? Is that what you're thinking? All right. What you just answered was this one. This is the one where the negative stuff on below bounces up. This one's different, because what this one is saying that x, if I stick in a negative for x, it thinks I put in a positive for x. This is the one where this side goes away and then I reflect it over. This is what you should have said, is that one. This one is the one you did say. If I had asked you for this, then you should take the stuff on the bottom and flip it up. So the final answer would look like that. Okay? So try one, everybody. Here is a picture. I want you to see if you understood the difference. To tell me this. Wait a minute, I put the absolute values on the wrong side. Sketch me what you think that would be. You got to think to yourself, is this the kind where it just reflects the stuff on the right over to the left? Or is this the kind where it flips the stuff from the bottom up? Again, there's two things. This is a different way. The red one, I'm going to change actually. I'm going to change its color to green, then I can draw its answer in green. This is the kind where the x's can't be negative anymore. So this part goes away. And this becomes a reflection of this part. I'm going to reflect this part here to the other side. And it looks like a gigantic M. Raise your hand if you had a big M. Good. And the other one, the absolute value one, where it's absolute value of the f of x, that's like saying y gets absolute valued. The y's can't be negative. That means this part down here has to flip up. So your answer on that one would look like this. Up instead of down. Up instead of down. Kind of like a mountain range or something. Remember that? Okay, and last blast from the past. Do you remember that on this kind of a problem, that I told you to start on the inside and do everything in the opposite of normal order, and then you go to the outside. Does that ring a bell? But do you remember me telling you that you could actually do it the exact opposite way of that? You could start on the outside, do it in normal order, then go to the inside, opposite order? That also works. Why can't you just say, well, I'm just going to do it the way you told us, and I'm going to start on the inside? What if test multiple choice and that's not one of the options? See what I'm saying? Much of it is. Not all, but much. So then, would you please write down what you think the right order is if you have to start on the outside? There's 5 things. 1, 2, 3, 4, 5. Believe me, you don't want to try to remember all 28 concepts in the last 3 days before the final. It's going to be really hard for you to learn everything then. So I'm starting now. So if you start on the outside, this would normally be first, and you do things in the normal order, so I should do that first. But there's really 2 things there. JR, what do you do first? In gymnastics, would you stretch before you flip or flip before you stretch? Yes. So, care to revise your answer? Stretch, and so say the stretch part correctly. Yep. All right. Next. Let's go over to the front row, Mr. H. Tell me what's next. What if I said flip wasn't a good word because it's not on the test? What's another option? There you go. Reflection over, which way? You are correct. It's an up-down flip, so it's a reflect over the X. All right, next thing, go to that, and that's up 17. Okay, then we go to the inside. What would normally be first? Now this one confuses a lot of people. Remember, parentheses are top priority, so that would normally be first, so we don't do that. We do the 2, and so this would be not 2 times wider. What? Half as wide. And last is the right 5. Did anybody have all of those in the right order? All right. So now we're actually done. All right. If we do a little bit of that each day, you'll really thank me when the day of the final comes because you won't have to study nearly as much. Okay? It'll be more fun now to not have to do it, but all right, page 264, 34 to 50 evens, 41, 43, 58, 64. Seems like a big assignment. It's really not. I think it's like 11 questions, something like that.